1.3. Here's a meme for you guys. Here's a meme for you guys. There's a meme on the board for you.
That's me, I'm trying. Huh?
Fine girlfriend.
I get it.
That doesn't apply to you.
Not to me, no. No, I already have my wife, so yeah.
Imagine being single.
Does not apply to me, okay? Hey, if we look over here, honor geometry. Monday, not married Monday though, because it's not the first Monday of the month. That was last time. You guys didn't have that though. You guys, you did. No, you didn't. No, you didn't. I think last did. Going back and forth, going bonkers. The 24th of August, the second funniest day of the month. SWBA students will be able to find lengths by using the distance formula and same with bisectors. Distance formula is pretty lit, okay? Not really, but you guys might think so, but probably not. Anyway, right? You're like, what did you just say? Okay? So, distance formula, okay? But first of all, let's talk about distance. Distance is also called length. We know this. We talked about this last time, right? The length of something is the same thing as its distance. And it's always represented by a positive number. We talked last time you can't have negative distance, can you? If I step backwards, I'm not taking a negative step. I still took one step. It just happened to be backwards rather than forwards to the side, okay? So to find the distance between two points normally, you just counted, right? Last time we just counted, or you can subtract the two numbers, okay? This time, if it's between, this is a lot to write, and I'm sorry, okay? If it's between 2 points on a coordinate plane, I need to make the space like way longer. 2 points on a coordinate plane, use the distance formula. If it's between 2 points on a coordinate plane, use the distance formula. Okay, I need to make that like way longer on the length. Okay, so sorry about that. Okay. So for an example, here's 2 points. We can't just count the distance to go 1, 2, 3, 4, 5, 6, and say this is 6 long. Okay, it doesn't work that way when it's not straight up and down or straight left and right, okay? Because we're dealing with two-dimensional space rather than just one-dimensional space, okay? So we have this fancy thing called the distance formula, okay? Distance is d. Lowercase d is equal to the square root of x2 minus x1 being squared plus y2 minus y1 being squared.
Confusion.
Are you confusion?
I am.
It's like slow.
You said we use calculators in this class?
Wait, that's
It
not your
really
hand.
feels like slow.
Alright, okay. So write it down, and then I'm going to talk about it a little bit, and it might make a little more sense as we keep going through, okay? If not, I'm sorry.
Geometry, not calculus too.
Actually, Calc 2 is my favorite math class, fun fact.
What?
I love Calc 2.
What about Calc 1? Was that like
Calc 2 was like good.
Problem.
Like, but I just like really love Calc 2.
Why?
Calc 3 didn't like as much. Differential equations didn't like as much.
What's the highest math?
It depends on who you ask, because once you get to a certain point, math just kind of ranges off. And it's not like, oh, this comes after this, which comes after this, which comes after this. It's like, oh, you have this math class, and you have this math class, and you have this math class, and you have this.
What if you took all of them? You're a genius.
How smart are you?
Okay.
Not that much.
So,
That's
So,
question.
here's what happens, okay? We're taking the square root of a lot of stuff. But first, we're taking our two different x's, x2 and x1. Those come from the x values of our coordinates. We take them and we subtract them. You square that. You take your y's, you subtract them, you square that. So you subtract your x's, square it. Subtract your y's, square it. Add them. And you square root. Okay?
That makes a lot
Now
of
this math here isn't actually going to be as hard as we think it is. Okay, it's not actually that intimidating. It's just a lot of steps. It's a lot of steps. Okay, Sarah.
I didn't catch what the words were for the top part.
Length, positive. Okay, I'll go back to you in a second. Max.
How do we know which one is X2 and X1?
Great question. It low-key doesn't matter.
Oh, then you're going to square it anyway.
Okay, and we'll talk about why it won't matter. Okay, we'll talk about why it won't matter in a bit. Okay, thank you. I appreciate that, Sierra. You're the real MVP. Okay, this is why you're my favorite, Sierra Whitley. Okay, Not even close. Now, it low-key doesn't matter which one we call x1 and x2, which one we call y2 and y1, okay? It doesn't matter, okay? So as we fill this out here, distance for this one is going to be the square root of a bunch. So now, which one do we want to call this? Do we want to call this x1 or x2?
2.
3.
Cool.
Yes.
I'm going to call this one y2 while we're at it then. I'm going to call this one x1 and y1 while we're at it.
Okay.
Okay? So x2 minus x1 would be negative 3 minus 3.
This hurts.
In parentheses, being squared. I'm just going to plug things into this formula, substitute them in. Plus, where did this
We get the second.
From the X
from
above.
x1, from our other x coordinate.
Well, I'm gonna feel this.
Okay? Big brain. Okay? Next, we're going to do the y. So we're going to do negative 2 minus 4. So negative 2 minus 4, and then we're going to square that. Now, I put this little thing here at the end of my square root. You guys may or may not have seen that before, okay? Some people do it, some people don't. It's a preference. You don't have to. I liked it. I like it because then I know, hey, this is where my square root ends. Everything before that is inside the square root. Some people don't like it, so you don't do it, okay? Either way. I like it, okay? So I do it. Any questions on where I got stuff when I plugged this in? Or why I plug things in certain places? Everyone understand that? What was that?
What is it on negative?
Because x2 was negative 3, so we plugged in negative 3. Then we had to subtract x1, so I put the subtraction. So when we're subtracting a positive 3, you subtract the plus sign. So just kind of what the numbers happen to be on this line. Does that make sense, Aiden? No. Okay? Any other questions on why things are this way in this formula right now? Sarah,
Could you switch the X? Wait, never
you
mind.
totally could, but we'll talk about that in a bit.
Okay.
Okay? Okay. Kelly. Yeah, it just happens to be. We just happen to call distance lowercase d. I don't remember why they what capital D is, but I just know like distance and like even like science, like distance equals rate divided per rate divided per rate equals distance divided by time. The d is lowercase in that too, so it just kind of happens to always be across the subjects. I'm not sure why. So according to order of operations, what would we do first? Parentheses. So we're gonna leave the square root here. What's negative 3 minus 3?
Negative 6.
Negative 6. And we're going to still square that. Plus, can we do this parenthesis at the same time?
Yeah.
Heck yeah, they're separate. What's negative 2 minus 4?
Negative 6.
Negative 6 again. And we're going to square that still. Questions on that step? What would we do next according to order of operations?
Exponent.
Exponent. What is negative 6 squared?
36.
Positive 36. Because negative 6 squared means negative 6 times negative 6. And a negative times a negative is a
Positive.
positive. Plus, what is negative 6 squared? 36 again.
Positive.
It's like we're on repeat, okay?
72.
It's like we're on repeat, okay? It's like we're on repeat, okay? It's like we're on repeat, okay? What is 36 plus 36? Square root of 72. Does anyone know what this is off the top of their head?
Nope.
Yep.
Okay? We don't. Levi, what is off the top of your head? Okay. Bill, what is off the top of your head? What?
No,
8.5.
8.48.
Nope. Okay.
8.48.
Nobody knows what it is off the top of your head? Cool.
8.49.
Okay. So here's the thing. If I asked you what was the square root of 64, what would you say?
8.
If I asked you what the square root of 81 was, what would you
Nine.
say?
Nine.
9. Okay. We could do those. Okay. Now, is this somewhere between the square root of 64 and the square root of 81?
Sir.
Yeah, it's between those two numbers. I know it's going to be somewhere between 8 and 9 estimate, but here's the thing. Everyone, if you have a smartphone, pull it out now.
Oh my gosh, he shows good things.
Oh, they got a phone,
The
but
day I saw the phone.
Yeah, you do the square root function on your phone.
I got it.
I do not think so.
Hold up.
Oh no.
Okay? Raise your hand if you don't have a calculator in front of you now on your phone or on your own calculator. You need your own calculator. Raise your hand if you don't have one, because I'm going to get you one. Okay?
It's 8.4852.
I told you what it was. You did.
Use it in the bag there, in the bag. Okay?
8.485.
So we can like that.
8.48.
137.
Oh.
No blurring. Listen to me, please. Okay, so I'm going to go through 2 sets of instructions here. First set of instructions is any iOS device, so the iPads, the phones, okay, iPhones, anything like that, an iPod, okay, or a Mac computer, anything like any Apple device. This will be this instruction, okay. What you do is you go into calculator, Okay, or you download a better calculator because the iPhone calculator is low-key trash. Okay, trust me, I can say that. I have an iPhone as well. The calculator is low-key trash. Okay,
It's like
So-
a Google phone.
so Androids have a way better calculator. Okay, regardless of
Yeah,
your
wow.
phone, Androids
Yeah.
have a better. Anyway, turn your phone sideways. You type in the number first. You type in 72 first. So this is only on iPhones, not on the scientific calculators, not on the Androids. Okay, you type in 72. Okay, then you on the far left of the screen, you go the second row over, second from the left, halfway. You see this little button that looks like this.
There's two.
That means square root. That 2 means square root. If there's a 3 there, that's cube root. You don't want that one. You
That's
type
on
in
my
72.
back row.
You type in square root, and you don't flirt. You write down your answer to the nearest hundredth. Hundredth is how many decimal places? 2. Write down your answer to the nearest hundredth. Now, if you have any question on the iPhone, or Apple devices, okay, you guys, freshmen, you guys can use that on your iPad as well, okay?
They don't
Now-
give us calculators.
You should have Calc 84 on there, or soon you should have Calc 84. It'll be pushed out to you. It is a nice app. Now, iPhone users, if you want to download a better calculator, it's free with in-app purchases, but it's free. It's called Calc 84. Calc 84, it's amazing, okay?
In-app purchase.
Now, if you want to, now if you have the other type of calculator, so if you have an Android phone, or if you have one of my scientific calculators, or a normal scientific calculator, okay? This is for you. What you would do is you would type in the square root button. You would hit the square root button. On the Android phone, you might have to turn it sideways. On the Android phone, you might have to swipe to the side, depending on your phone, okay? If you have one of the scientific calculators, you would hit the second button on the top left. You'd hit the second button on the top left of the screen, and then halfway down next to the 7 on the far left, there's this button that says x squared. If you look right above the button that says x squared in a slightly lighter font, the same font, same color, slightly lighter color, and the same color as the second button, you should see the square root symbol. So you push second, then you push the x squared button, that'll get you that lighter color. Okay? So push here. Okay. Push second. And then push x squared. So that got you the square root symbol.
It's
Which is right above this in the same color. Okay? So then after you push the square root button, you push 72 and push
Is
enter.
this the calculator you're talking about?
Yep, it's amazing. Nearest hundredth. Okay? Anyone have any questions on either calculator? Anyone have any questions on how to use either type of calculator here? Okay. So, to the nearest hundredth, what did we get?
8.49.
No, 49.
8.49, okay? Now here's the thing. Is it exactly 8.49?
No.
No, we call it approximate. Does anyone know what symbol we use for approximate instead of equal, okay? We use the little what? The squiggly line, okay? Here's how I like to think about it. This is equal, it's straight, it's firm, we know this, we're confident in it. But if you're kind of nervous, you might be shaking a little bit, okay? We're nervous, it's not exactly this, it's kind of this, okay? So it's approximately 8.49. Distance is approximately 8.49, or exactly the square root of 72. As soon as we round it, it's no longer exactly that. So, Mr. Kossel sometimes might ask for the exact answer. If I ask for the exact answer, I want this. If I ask for the approximate answer, I want this, rounded to however many numbers. If I ask for both, I want both. Does that make sense?
Can we just always give those two and have a
Sure.
Nice.
Okay, wouldn't that be
Let's
format?
format.
Okay.
Follow.
Questions on this? Now I said a moment ago, it low-key didn't matter what order you went in for x1 and x2 and y1 and y2. Let me show you why. Okay? So if over here, I started off again, and I do, instead of negative 3 minus 3, I switch it around. I do 3 minus negative 3.
Whoa.
Plus, and instead of negative 2 minus 4, I do 4 minus negative 2.
Is that just to check your answer?
Okay? No, I'm just showing you that it didn't matter which way we went. So now, what happens when I have two negatives in a row like that, though?
Positive.
They're positive, right? You add the opposite or keep change something that's known as. What is 3 plus 3?
6.
6. So I'm going to have 6 squared. What is 4 minus negative 2? 6. Now, question, what is 6 squared?
32.
36. What is 6 squared now? Over here on this one.
36.
36, it didn't change? Okay, cool. So wait, am I going to get the same exact thing?
Yes.
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 Here's what happens. Regardless, these numbers, 3 and negative 3, are 6 apart. So whether you subtract them one way or the other, the absolute value will be 6. So whether we get negative 6 or positive 6 won't matter, because when we square it, can you end up getting a negative number after you square something?
No.
No, because if it's negative, you take a
So
negative
that's
times a
the whole
negative.
reason we square it and then square root it.
Actually no, because you have to add them first and then square root it. There's actually a different reason. It comes from the Pythagorean theorem. This formula is actually derived from the Pythagorean theorem. Fun fact. So that's why we square root it. But because we square them, it doesn't matter which order we put them in. So you can just do whatever is convenient. So if you would rather do one minus the other, awesome. And if you want to switch them around, and you want to do maybe 3 first on this one, but you want to do 2 first on this one, then you can do that. It doesn't matter. As long as you keep your x's together and your y's together, okay? You're not going to intermingle. Okay, Bill.
Okay, so this is a legitimate question. I'm not trying to be dumb or funny.
Okay.
What jobs would this be used for?
Okay, good question. So you might need to find this if you're doing the distance between 2 different actual locations. Now, a lot of times there might be a technology that's used for this now. But let's say engineering. Okay, you need to figure out how far apart is the distance across the intersection in order to figure out where to put the signs at and that kind of stuff. Okay, so you might need to use a distance formula between these 2 exact locations. So even though it might not be on a plane like this, you would still use something very similar to this. Or let's say you're using a device, some technology for it, like a calculator for it, a special calculator for this. Somebody has to write the code for that. So whoever's writing the code for that would need to know this. So stuff like that. Does that make sense?
Yeah.
Yeah. And thank you for prefacing that, by the way, Kelly.
Essentially, this is like base knowledge for more in-depth things.
Yes. Great question. Great point there. Okay. Yes.
I used this last year in trig, and it does get easier. There is a better formula. Just it's good to learn this formula now, so you know what you're doing further on.
Beautiful. I love that. Okay. Right. Good old Debbie. Okay. Any other questions?
Do we have to do the next two?
Yes. We get to do the next 2.
Ooh.
Actually, I want you guys to try letter A, and depending on how we do with it, we might not do the other one.
What?
Yep. So between these 2 points now,
Is it X, Y, or is it Y, X?
X, X, Y, alphabetical.
Oh.
Once you have it or have questions, I want you to raise your hand.
What?
Yep.
Oh.
Sorry, I did it when I'm not doing it. Oh, yeah.
Can we use our phone?
For the calculators, yes, you can use your phones to log calculator row.
Can we just put
Ian's mom would be proud of that one.
What? What? Just put the class in.
Needs to be like, where's your work?
In the calculator?
I did that once, and I did have it in the
You
calendar.
actually could do that.
Where's your work in the computer?
Oh,
I
no,
have
you
my-
can.
I have my history. of
Yeah,
calendar
yeah.
and-
Yeah, you could.
I'm not gonna stop
It'd be a little bit. You just have to do a lot of parentheses.
Yeah, no.
Oh, good luck.
I.
I don't even know what
What's 2 squared?
One minus.
Not a number.
Not a number.
So here's the thing. You actually need a double set of parentheses there. Too. Why don't you put one more parenthesis there? Okay. And then and then you need
Who knows?
another set of parentheses.
169.
Yeah.
Don't even give me that look.
There you go.
That goes.
Yep.
So 1604.
But I want to know what it is exactly too. So you can have to go through.
Remember that says right.
But what is it exactly? That's an approximate.
I got
That's
this
probably rounded up.
69.
Ooh.
Yeah.
But even if you do type this all the way into a calculator, like some of us are doing, which is clever and I like it, you're gonna have to go through and do it by hand because I want to know what it is exactly as well. Okay. That's what I mean.
It doesn't give you. It doesn't give you. It gives you the
That's what I mean.
We need to have the.
My goal is okay. Why else would I become a math teacher if I didn't want to make you guys cry?
What?
Exactly.
Like, what other reason is that?
Specifically asking the table, specifically.
I'm gonna start sobbing. You're gonna
What?
quit.
Specifically for tables where people cry.
Yes, that's the goal. Okay, at some sort of table or desk. Okay. Now, if it happens in this room, that's even better. Just kidding. I don't actually want to make you guys cry.
Lies.
clear.
Low key.
Well,
That's
I
why
think
we're
that's
not.
So cute. No, that's Mr. Howard joke.
What? No, that's the approximation.
That's not.
I'll give it a round
The
of
approximation.
You don't have
You need to like, you need like a
I-
square root. That's the-
Howard and
Yeah,
Liam.
Mr. Howard, this is my exact.
Oh, no, I think
He's scary, but like, I'm like scary.
I
I have a really fancy consideration. It's very frequent.
Hey, if you're done, I'm gonna ask you to wait patiently and raise your hand for me to
I
check
like
it.
a Zoom.
Is that enough squiggly line?
It's Great Check Monday.
Maybe a couple more.
No, I want you to do it. No, that's good.
Yep. So yeah, they're okay together.
What if it comes out?
Yeah, that's good. Yeah. I'll talk about that in a moment.
Wait. It was
Oh, calculator in a bag.
Okay, great.
Where are we going?
Yeah, I have a 96.
Where are we going?
What?
So let's go. Where are we going?
Oh.
Let's talk about this one up here, okay? Does somebody want to help me set this one up?
No.
D equals.
D equals negative 5 minus 8.
Okay, does it matter whether we do the 8 or the negative 5 first?
No.
Super doesn't. Go on your preference. Okay? Plus.
Or are we going the other way? We can do
Okay, 6 minus negative 4 is just 6 plus 4.
that and then.
Life hacking.
No.
Positive. Okay? Go ahead, Kaya.
13
Okay.
plus.
I'll adjust it for Okay? What is 13 squared?
Life.
169. Have you guys memorized any of those squares?
Yes.
2 times 2 is 4.
What?
2 times 2 is 4.
Actually,
Yes.
everything is 12 and under.
I have a question.
Memorize it.
For the D, I did the equation and I got exactly 5.
We're not on B yet, though.
I know, but like
Hold on
I got
for a moment
exactly
there,
5.
okay?
One.
Plus 10 squared is 100. Okay?
Yeah.
So the square root of 269 is exactly what it is. What is this approximately, though?
16.4.
16.40, 16.4 is the exact, okay? Questions on that one?
Oh,
Okay. Let's look at letter B as a point, okay? Now, I'm just going to do this up here, speed racer fashion. Okay, you guys cool with that? You guys don't have to write it down if you want. Come on. Change color again.
Isn't that like the same color?
Okay, it is. It accidentally changed on me. Okay. So, I'm not hitting it hard enough. Okay. So, D is equal to the square root of, let's do 3 plus 1, because it'll be subtracted, minus negative 1 plus, oh, come on. That's not square root, parentheses. 4 minus 1 squared, that would be 4 squared plus 3 squared, yeah. Which would be 16 plus 9. Now we're going to get D is equal to the square root of 25. What do we notice about 25 besides it's extremely funny? Perfect square. So D is 5. Now here's the thing. When you get a perfect square like this, there's no approximate answer. You didn't have to round. So instead of there being exact, approximate, 2 different answers, this is our one answer. So it's only the only reason we have 2 different answers, the only reason we need an approximate on these other ones is because it wasn't a perfect square.
I totally
Here,
got that
perfect
right.
square, we only need one answer.
How did your handwriting get better? It was like terrible in the beginning and then it got
Question. Like as we went down.
yeah.
You have bad handwriting? Or is it?
Oh, I had bad handwriting.
I have that.
How do you write your
That's a
name?
good question.
Why is 25 a funny number? I don't get it.
So fun ball.
I'm pretty sure I'm funny gauge.
Because 24 is not.
My parents didn't let me watch SpongeBob. I'm pretty sure I'm funny gauge. It
I
was
didn't watch
scary.
SpongeBob. How do you write your name?
My mom said it would make
Right,
me
right.
sick.
Oh,
you!
This is how he writes it. He goes like
Two
this.
circles.
You do the 2 circles?
He goes a
That's
circle around a
gross.
circle. You weird
Yeah,
out.
you're like an O with a belt around it.
Liam.
Hey, we're gonna use half the time.
Liam.
5?
What's weird? One dead baby.
Liam.
2 dead babies.
Oh.
How
You know how
That's
people write
unnatural.
their, it's like a thing and then like the top hat one?
You what?
That sounds wrong.
Two
It
circles.
is wrong.
I write it
Liam.
like this. I go like this.
Liam.
2.
Yeah, that's wrong.
No, it's not.
Do a figure
Why?
eight.
That's how you.
It's in one movement.
No, that's how you teach. You do.
Like that.
How you teach?
Liam. And I can do the go like this.
Oof.
What are
Okay.
your options?
Let's talk about a midpoint. A midpoint. It kind of sounds like the what point?
Middle.
Middle.
Enter.
The midpoint is the point that divides the segment into two congruent parts. Now here's the thing, or to two congruent segments if you want. I'm going to be lazy. I don't want to write out the word congruent, so I'm going to do that. Congruent symbol. If you want to write out the word congruent, you totally can. That's the beauty of this.
Two
Okay.
circles. One A.
So, between A and B, I'm going to put a midpoint here. Now, is that necessarily exactly in the middle? It might be close, okay? But how can I mark this to be exactly in the middle if we have human error? Those little tick marks. Boom. Now, do we know it's in the middle?
Yes,
Yeah, so even if I was off by a little bit, we know it's in the middle. So, point M is the midpoint of segment AB. So, segment AM is congruent to what segment?
BM.
BM, or MB, really doesn't matter.
PM.
Okay? Bowel movement. Okay. So, this is talking about the segment, though. This is talking about the segment itself. The segments are congruent. Now, if the segments are congruent, in terms of length, that tells us the measure of segment AM is congruent to what measure? Measure of segment what?
The other
BM.
BM, MB, BM, MB. We don't care the other one. Okay? So remember, that's just kind of hammering in the fact that segments are congruent, measures or lengths or distances are equal. Okay?
Does this count?
I don't know if I on our movies.
How's the first
I mean, technically. Okay? Continuing on, if we don't have any questions on this. Okay? Now we're right here. Example 3. Point M is midpoint of BW, segment BW. Find the length of BM. So M, midpoint, we have them marked here that those two things are congruent because they're both half. How could we find the measure of segment BM? What kind of equation could we do? Put them together how?
Math.
Math. Okay, we put them together.
Genius.
Do the
Okay,
thing.
what? Add like terms. Okay. Saren?
Do the I don't know.
Okay. What do we know about these two segments? They're equal in length because they're congruent.
Yes, and check.
So if they're equal in length, what could we do algebra-wise with them?
Multiply one of them, the equations by.
My lights are going like
Okay.
All of our lights are going.
If they're equal in length, could I set their lengths equal? That might sound straightforward if I say it. If they're equal in length, because they're congruent, can I set their length equal? Yes. Yes. Good luck.
oh.
Okay. Questions on why I can do that? I only look confused. You're what? You're not confused? Okay. Saren,
I have a question in general. Why are the lights flashing?
I don't know.
They
Okay.
want to.
It's matrix.
Oh, it's
Yes.
Why do you always say good luck?
it's amazing. It's just like
I hope it goes well.
Well, like, makes it feel like something bad's gonna happen.
Well, I hope not.
That's why I say good luck.
Yeah, like I don't. That's why I say, look, I don't want something bad to happen. You want something bad to happen?
yes.
Feels like you're foreshadowing.
So, 4x minus 1 is equal to 3x plus 3. Any questions on why we can set it up this way?
Because
Okay.
math.
Because math, okay? Anytime you hear that two things are congruent, bells and whistles and cowbells should be going off in your head telling us, hey, we should set them equal.
I've never heard of cowbell.
Okay, you never heard of cowbell? Oh, that's gonna change.
Sarah.
Why did you say that?
Okay, you're gonna learn today. Okay. So now, how can I solve this equation?
Math.
Math. Okay, Kyle.
Minus, 3.
Okay, subtract 3x from both sides.
So it's positive.
I like it, okay? So 3x minus 3x is 0. 4x minus 3x is just x or 1x. X minus 1 is equal to 3. Now what? 1? Hey, 1 plus 1 is 0. X is 4. Now wait, were we told to even find x?
No.
No, how does that even help us?
Because you need to have an F in order to solve the equation.
We can plug it in VM.
It doesn't help.
Okay, so instead of 4 times x minus 1, it's going to be 4 times 4 minus 1.
This is math.
So 16 minus 1 is 15.
Oh, they're equal. They're
Show the
congruent.
measure of segment BM
no. They're equal.
is 15. Now, Bill, what did you notice?
They're congruent.
They're congruent because if I plug 4 into the other one, what do I get?
The same thing.
The same thing, 15. Now, should they have been congruent?
No.
Yes.
Yeah,
Because they
that's
have
what we were
lines.
told to start, okay? So is that a way you can check your work?
Yes.
Yeah, you can totally check your work that way, okay? By plugging it into the other one and make sure you get the same exact thing, but they're supposed to be congruent. Now, once again, we weren't asked to find x, but we needed to find x in order to find this. Here's a geometry tip, okay? Here's a geometry tip. I'm gonna call this a pro game remove, okay? Anytime you're told to find the length or measure of something, and it's like a part, like a segment or something like that, you're probably gonna have to find an x first, okay? So anytime you're asked to find something like this, you're gonna have to find x in order to plug it in to actually find that part, okay? Does that make sense? Okay? Hi, Mr. Malley. Okay. Questions before I move on? Does anyone still need this?
Who's Mr. Malley?
It just looks
No,
like.
no,
I
I'm
mean,
going
because
to
none of us can see
He
how that
replaced
window was
Mr.
moving.
Brothers.
Yeah. Yeah, they're crazy. He's out there at the gate. Mr. Malley's our athletic director, activities director. Okay?
Huh?
Mr. Malley's our athletic and activities director.
Ah.
He's a pretty chill dude.
The chimney.
Okay. Segment bisector. Bi means what? Two, right? Like bicycle. Okay. So bisector. Sector kind of looks like section. Okay. Two sections is what I want us to think of with bisect or bisector. So a segment bisector is a point, ray, line, segment, or plane. Basically anything that we've learned so far. That intersects or cuts through or touches. Intersects the segment at its midpoint. It intersects the segment at its midpoint. So if it goes through the midpoint of something, it essentially cuts it in half, aka a midpoint or a segment bisector bisects a segment. Bisects is going to be the same thing as cut in half. It means it cuts it in half. So I want you guys to even write this in here. Cuts in half. Because we're going to use this terminology a lot in here of saying it's bisecting or it's bisected or something bisects. And it always just means that it's cutting it in half. So if I were to draw a segment bisector in here, I could have the midpoint M. Let's say it's the midpoint. And then maybe I have this segment here. Now is M necessarily in the middle of C and D there?
No.
No, okay. But is M in the middle of A and B?
Yes.
Yeah. So segment CD, which M is on segment CD, is cutting through A, B in half, right? AKA it means it's bisecting it because it cuts it in two equal halves. So we would say that segment CD is the bisector of segment AB. We would say segment CD is the bisector of segment AB. From that, aka so, segment AM is congruent to what segment?
AB.
Maybe.
Or no, NB.
MB or BM, either one.
BM.
And their measures are equal as well. Measure of segment AM is going to be equal to the measure of segment MB. Okay, I had to do yourself a question.
Can the thing that you put in that go across?
Yeah,
Always have to
great question. So Kai was asking, hey, can the segment bisector, the segment CD that's cutting in half, does that have to go straight up and down? No, it can go through at any angle anywhere, as long as it's just cutting this thing in half. So it could be a line that goes through at any angle, a segment that goes through at any angle, a point, it can be a plane. Yes, Aiden.
Meant to put AB in the bisector of CB. Is it the same thing?
Because is AB cutting CD in half?
No.
No, CD is not getting cut in half.
We don't know.
So CD is getting, technically we don't know. CD is cutting AB in half, though, and we know that. Okay? So we're saying this cuts this in half. This is the bisector of this. Did I answer your
Oh, that's
question?
because you did that.
Yes. Okay. Any other questions on this? Okay. Yank, Dope, and Liddy.
I'm confusing myself on what I did.
Alrighty. Okay. So on example 4, we're supposed to identify the segment bisector of PQ, then find the measure of MQ. So what is bisecting segment PQ here? What is cutting it in half?
And line L.
Line L. Line L is cutting this segment PQ in half. So what is the segment bisector? Line L. Here's how I can write that. I'm going to abbreviate it because I'm lazy. Seg is segment. And I'm going to say bisector is bis. Segment bisector is
Sigbus.
line L. So I'm going to do a lowercase l. However you want to write your lowercase l is fine. I do mine with a little tail at the end. That way I can distinguish it from a 1. Whoa. Big, big brain. Okay,
Oh, I just wrote it in cursive.
that's fine. I think that's super chill if we would do lowercase all in cursive. It's the little loop thing that's actually kind of right here.
Yeah, I can't do that. That is
Do it.
Jacob would show you. Jacob always writes in cursive.
Yes.
You're like Matt.
No, it,
Yeah.
gross.
Okay.
What's that math?
Alright, so now, how can I find the measure of segment MQ? Can anyone help me find the segment of measurement MQ? How would I go about that?
I wasn't there.
Levi,
Find the x of both sides.
okay, find x. Okay, so what was the equation you said?
5x minus 3 and then equals 11 minus 2x.
That's exactly, that would be our equation here, okay? Is 5x minus 3 equals 11 minus 2x. Then so big picture, we set up this equation, because these are congruent, we can set them equal. This will help us find x, which can then help us plug it in to find MQ, which is our goal. So big picture, that's why we're doing this, okay? I want you guys to understand the why, not just saying, here's the steps, memorize, okay? I want you guys to understand the why. Math is about thinking, critical thinking, okay? So I want us to understand why we're doing it.
That's why I haven't
Move, okay? Or it's because you didn't turn in your syllabus. Okay, either way. So now how would I solve this equation? Levi.
Nah.
Add 2x.
Okay, add 2x. 7x minus 3 equals 11. Okay, now what?
Add 3.
Add 3, dope. 7x is 14. There's someone spoil it, divide by 7, and x is 2. So I need to plug it in. Which one should I plug it into?
The one on the left.
Both of them.
DM is not plugged in.
It doesn't matter. Why does it matter?
It's
It's
just
right here.
They should be congruent. Now, here's the thing. What if we did something wrong? Would it matter then?
Yes.
Yeah, okay, so you can plug it into both to check. But which one do we actually need the answer of regardless?
DM.
P, M, Q, Q. Okay, but you can plug it into either, okay, because they should be congruent. Let's do it on the right for now, though. 11 minus 2 times 2. Don't confuse it with what a vowel or unit wears, 2, 2. Okay. So 11 minus 4 is 7. So we're told the segment bisector is line L, is what we found, excuse me. We're not told that, we are saying that. And then our other answer is that the measure of segment MQ is 7. And that would be our answer, or our answers.
Can we just put base 7 on the page and keep it?
No. Definitely let me in.
M, Q.
Any other questions on this?
How do you put a Q?
Anyone still need this?
Aimed it.
Okay. We're gonna skip the next one. We're gonna do it the same exact way. We have this thing called a midpoint formula, okay? A formula to find a midpoint if we're in a coordinate plane. Okay? Now, here's the thing.
Oh, that didn't look very bad.
So,
In this
we're gonna find the x coordinate, and then we're gonna find the y coordinate. Then you have your x and your y, and you'll know where it's at. So for the x coordinate of the midpoint, let's call the midpoint capital M, it's going to be the averages of x1 and x2. Where do we think x1 and x2 would come from?
X2 and X1.
It
From
listed
two
X1 and
different,
X2.
X
From 2 different points, whatever the endpoints are. So we're trying to find a midpoint, meaning there's 2 endpoints. If we're trying to find a midpoint, that means we have 2 endpoints somewhere. Okay? So x1 and x2 are the x's of those points. Now, how do you find the average of something in general?
And then together divide by however many there are.
Add them together, divide by however many there are. So if you're adding 5 things together, you're going to divide by 5. If you're adding 3 things together, you're going to divide by 3. Here, how many things are we adding together?
2.
x1 plus x2 divided by 2. Is that even really a formula?
yeah.
It is, but it isn't. If you know how to find the average, that's good enough for me. Now, comma, because this is written as x comma y right now. This is written as x comma y. So that's why this comma is here. The y, same thing. Y coordinate of the midpoint is the averages, but instead of x1 and x2, what do we think is going to be the averages of?
Y1 and Y2.
y1 and y2, so it's going to be the averages of the y's. Same thing here, y1 plus y2 divided by 2, because we have two different things we're adding.
So the end answer is the coordinate.
The end answer will be a coordinate as x comma y. So we're just finding the x coordinate, we're finding the y coordinate, we're saying, hey, this is our actual order pair. Questions? Okay, go on to the next page. We're going to do a couple problems here. So, if I were to find the coordinates of this midpoint, I need to find the averages of the two x's and the average of the two y's and put them together in a coordinate. Now, if you want to write this out, you can. If you don't want to write it out, you don't have to. So if this is something you can do in your head without writing out the formula, great. If this is something you want to write out the formula for, great. Okay? Did I say one option is better?
No.
No, they're both options. Okay? Let's say though we're writing midpoint m. Okay, midpoint m is going to be something comma something. So we said it's x1 plus x2 over 2 and y1 plus y2 over 2. Now does the order we add things in matter?
No.
No. So does it really matter if I put which x I put first? No. Does it matter which y I put first? No. Can I mix up my x's and y's?
No.
No. Okay. So what would my x value be? I do what plus what divided by 2?
1 plus 4.
1 plus 4, or 4 plus 1, we super don't care. Okay, and then y's would be what? Negative 3 plus 2, or 2 plus negative 3. Once again, super don't care which one it is. Either way, those are both being divided by 2, separately. Now once again, the comma's here because this is going to be dividing our x comma y. Okay? So what is 1 plus 4?
5.
5 divided by 2. What is negative 3 plus 2? Negative 1 divided by 2. Now we can leave them as a fraction, but typically speaking, when we're doing coordinates, we prefer decimals. Okay, what is 5 over 2 in decimal?
2.5.
2.5. Well, thank you for raising your hand, Bill. Bill, what is negative 1/2 in decimal?
Negative 0.5.
Yeah, negative 0.5. You can put a 0.52 if you want, but either way, it's 4.5. So it's negative 0.5. Now, if we were to look at our graph here, does this look accurate?
Yeah.
2.5 comma negative 5? Negative 0.5, excuse me?
Yeah.
Yeah. So this would be our midpoint m. So our midpoint m is at 2.5 comma negative 0.5. Now, if you just want to look at this and say 1 and 4, okay, what's halfway between them? And you say, oh, I know it's 2.5, or you just want to say 1 plus 4 is 5 divided by 2 is 2.5, write your answer. And if you just want to say, for the y's, 2 plus negative 3, that's negative 1. Half of that is negative 0.5, and you want to avoid writing this, that's fine. Does that make sense, what I said there? Okay, if not, I'll show it in a second. Okay, so I want you guys to try letter B on example 6. Okay, we just did letter A, I'm going to try letter B. Now, some of us might be able to look at this and say, okay, my midpoint's just going to be, the x's are going to be halfway between them, the y's are going to be halfway between them, because that's what the average is. It's going to find the middle of those. So I could say, what's halfway between 6 and 10? 8. Now, if you wanted to do 6 plus 10 is 16 divided by 2 is 8, you can as well. 8. What's halfway between negative 3 and 5? 1. Now, if you don't know, that's 4 away from each. You could add negative 3 plus 5, get 2, divide 2 by 1. Negative 8 comma 1, call it great. And boom, that's my answer. 8 comma 1 is my midpoint. If that didn't make sense to you, you can go back to doing our actual formula and do 6 plus 10 divided by 2, and then do negative 3 plus 5 divided by 2, and we're going to get the same exact spot. 6 plus 10 is 16 divided by 2, negative 3 plus 5 is 2 divided by 2. 16 divided by 2 is 1, or excuse me, is 8. Let me try that again. And then 2 divided by 2 is 1. So you still get 8 comma 1 either way. One is doing the paper on by hand. One is doing the math by hand on paper. One is doing the math in your head. Questions on that? Whichever one of those makes sense to you is what I want you to do. Okay. We're gonna skip this last one. We're gonna go down. Now we're gonna say we have a missing endpoint now. If P is the midpoint, so here P is our midpoint, so we're given our midpoint, and we're given an endpoint. So what are we missing now?
Everything else.
The second endpoint. Okay, we have a midpoint, we have an endpoint, we're missing the second endpoint. There's 2 different ways we can do this problem. We're gonna talk over both briefly. So the first way is doing the same math we just did. We said our midpoint formula was x1 plus x2 over 2 for the x's, and the y's was the same, but just y's, right? Same idea. This would equal the x of the midpoint. Is it okay if I call it xm, like x midpoint?
Yeah.
It's like the first x for the endpoint, second x for the endpoint, midpoint x. Okay, xm is midpoint x. Hey, Julian. Okay. So if we do our averages like this, okay, averages, this is what we're gonna call it, because we do the average in order to get that, like we did earlier. We're just gonna plug in what we know. We know one of the endpoints is -5. We don't know the other one, so we'll call it x sub 2, or x2. Divide by 2, and we know the midpoint is -2. Could we solve this equation for the other x?
Wait, I'm confused.
So here's what I did, is I took our midpoint formula, where we just take the 2 endpoints, 2 x's of the endpoints, add them and divide by 2, and that's our midpoint. And I just inserted what I knew. I said, hey, this time, I don't know the other endpoint, but I do know the midpoint. So I'm gonna put in the midpoint and solve for the endpoint. Okay, does that make any sense or no?
No, I'm missing that.
So that would be
Okay.
-3.
Okay, so then we could go at this, and what would we have to do first in order to solve? Multiply by 2, because everything's being divided by 2. We'll simplify, so we'll have -5 plus x2 equals or somebody else almost flipped it. Okay, so then we add 5, and what's x2? 1. So for our missing endpoint of EG, so G is 1 comma something. In order to find what it is, we need to do the same thing but with the y's. So we'll do fill in the same thing with our y's now. So we know an endpoint is 4. We don't know the other endpoint, so y2. We know we're going to divide by 2, and we know it's going to equal the midpoint of the y, which we know to be 5 because we're given the midpoint. And we could go about and solve this one in the same exact fashion. Multiply by 2. Multiply by 2. 4 plus y2 is equal to 10. Subtract 4 and y2 is equal to what? 6. So our missing endpoint is 1 comma 6.
So you're taking the endpoint and then putting the midpoint on the end of the equation.
And is solving for the missing endpoint. Does that make sense to you now? Kind of. Okay, we're a little bit better. That's better than earlier. Our second way of doing this is if you have a graph. We can plot these points. -2 comma 5. Let's plot that and label it P if we know it's our midpoint. And then -5 comma 4 is E. So if our endpoint's over here and it goes over here to the midpoint, where do we know our other endpoint's going to be? Is our other endpoint going to be on the left or the right of P? It has to be on the right, because P's in the middle of them. Now we know P's halfway between the two, right? So if I went 1, 2, 3 to the right to go from my endpoint to the midpoint, how far am I going to have to go to the right again? 1, 2, 3. So I know my x value is 1. Did my x value end up being 1?
Yeah.
How far up did I go from our endpoint to our midpoint? 1. So how far up am I going to have to go again? 1. 1 comma 6.
Oh, this
If
is-
you have a graph, is that easier?
Yo,
Yeah. If you don't have a graph, is that easier?
no.
No, you don't have a graph. Okay.
So you're saying that you stuff by
Now you could also do this same. Sorry, what was that? Okay. Now we could really truly do this as well on this, and let me show you kind of how that would work. Okay, if you don't want to write this out. Okay, and this is the last thing we'll do today. I know we're kind of running at the end here. Sorry about that. So you could say midpoint, endpoint. Well, how far away is 1 from -2?
3.
3. We're going to have to go 3 more away, but toward the midpoint. So we're going to have to add 3 to this and get 4. Same thing, how far is 2 away from 2?
Right.
It's not. 0. So we have to go 0 away from 2, and we're going to get 4, 2. If I graph this out, we'll see if we get the same exact thing. 1 comma 2 is P, -2 comma 2 is P. Well, I know my midpoint has to be, or my endpoint has to be on the other side of the midpoint. 1, 2, 3 to the right, or 1, 2, 3 to the right again. I didn't go up or down. So I ended up getting 4, comma 2. Did that make sense at all to anyone how I just did that one?
Wait,
that may
so the top one, how did you get 4?
Yeah, I got 4 because I said, here I just said how far away are the x's. I basically, I counted and said they're 3 apart. I did the same thing here, but without counting. How far away is -2 from 1? How far are the x's apart? 3. So I know I went 3 up from endpoint to midpoint. So the midpoint to my other endpoint, I'm going to have to go 3 up again. So I went 1 plus 3 is 4. So I said, hey, how did I get from -2 to 1? I added 3.
Oh.
So I'm going to have to add 3 again to get to here. Here, how far did I go from -5 to -2? I added 3. I'm going to have to add 3 again to get 1. How far did I go from 4 to 5? I added 1. I'm going to have to add 1 again here.
I get it.
It's the same thing as here, just without the graph. Okay? Hopefully that makes a little bit of sense. If it doesn't, I'm sorry. We're not going to do that discussion part, though. We're not going to do that discussion part. And I am going to pass out our homework, because I'm a media head who gives out homework.
no homework.
I'm dead inside.
You should look at movies.
What means we just don't you have to like
Oh, I'm
collect
not
our
gonna
desk?
do this.
You know, when you also your desk makes funny sounds.
Well, stop kicking them.
Your desk makes funny sounds.
First of all, you start hitting my desk, and then you start kicking my desk.
Your desk hit me.
Your desk is
Oh, sure. I'm sure the desk moved and hit you.
Yep,
That's probably what happened.
it did.
Yep.
never know.
Like
My
that
desk gets
fan.
there and I'm throwing hands. I'm about to fuck you, desk.
Put the tensions.
I'm pretty close.
Oh, oh.
You're the real MVP. All right. Unfortunately, we are pretty close to class ending, so we're gonna wipe him down in a couple minutes. But if you still want to work for a little bit, you can.
No, I don't.
No, I don't.